We have one last concept to review before we wrap up Chapter 3. This concept is going to be really important as we move into Unit 5 with confidence intervals and hypothesis testing. So we're looking here at the difference between sample statistics and population parameters. Now you may have noticed that when we talk about the mean, sometimes we use the symbol x with a bar over the top, and sometimes we use that Greek letter mu. So the difference here is where that is being calculated at. So if I'm calculating the mean or making any sort of calculation from my sample data, that's going to be referred to as a statistic. If I'm making a calculation from my entire population, maybe through a census or something of that sort, then it's going to be referred to as a population parameter. This population parameter is also going to change a little bit as we move into Unit 5 because it can be a calculation, but it can also be a claim that someone in authority is making regarding that population. So if a battery company said their batteries last 300 hours, then they're making a claim about that population. Okay, so let's see which symbols go where. So if I'm working with sample statistics, I use the English alphabet. Sometimes they have lines or hats or things over the top of the letters, but those are typically an indicator that you're getting something from the sample. So the mean, if it's calculated from the sample, is referred to as x bar, so it's x with a line over the top, and the standard deviation is just the letter S for standard deviation. If I'm working with my entire population, then that mean is going to be the Greek letter mu, and the standard deviation is going to be the Greek letter sigma. So that's how we kind of keep that straight. If you see Greek letters, you're typically talking about something that's coming from the population. All right, so let's give this a try. You'll find on your notes, here's one about batteries. So it says, Duracell manufactures batteries the CEO claims will last an average of 300 hours under normal use. So there's that claim from authority. A researcher randomly selected 20 batteries from the production line and tested these batteries. The tested batteries had a mean lifespan of 270 hours with a standard deviation of 50 hours. So I would love for you to go ahead and pause the video, identify the sample and the population, and then see if you have a sample mean and standard deviation and population mean and standard deviation. So if you don't have one of those, and I think at least one of them is missing, then just put NA. All right, so go ahead and pause the video and give that a try. Okay, so hopefully you gave this a try. Now our sample here is going to be those 20 randomly selected batteries from the production line. So I did note that that was a simple random sample. And then my population most likely is going to be all Duracell batteries on that production line. That seems like that would be a reasonable population. The leftover numbers here, so we have a 300, we have a 270, and a 50. Those haven't been used yet. So our tested batteries had a mean of 270, so that's going to be X bar, and a standard deviation of 50. So you should see that 50 show up here. So we have everything from our sample, and that's awesome. For the last number we have left, it says the CEO claims these batteries are going to last an average of 300. So average is another word for the mean, and this is a claim by somebody in authority about the entire population. So our population mean mu is 300, and now we're out of numbers. So our population standard deviation is NA. All right, we have one more example. So hopefully this went well, but if not, hopefully you learned a little bit that you can apply on this next problem. So the R.R. Boker Company collects information on the retail prices of books and publishes its finding in an annual library and book trade almanac. This year's retail prices for 40 randomly selected history books has been collected and resulted in a mean of $81.44 with a standard deviation of $8.09. At the 1% significance level, did the data provide sufficient evidence to conclude that this year's mean retail price of all history books has increased over previous years? You may assume that the population standard deviation of prices for this year's history books is $7.61. So you'll notice that there is a question in there, and I left that in there because this is actually a problem we're going to solve when we get into Unit 5. And to be able to solve that problem, you do have to be able to identify those statistics and parameters. And that's what we're going to do. And when we get to Unit 5, we'll actually evaluate this and see if we have that evidence that they're talking about. So pause the video, give this one a try. Last problem in Chapter 3. All right, so our sample here, it says they collected the retail prices for 40 randomly selected history books. So there is my 40 history books and SRS is noted. Then my population should be all of the history books published that year. The 40 that they randomly selected, it said those 40 had a mean of $81.44 and a standard deviation of 809. So both of those are going to be statistics. That'll be X bar and S for mean and standard deviation. And then let's see, what numbers do we have left? So we have this 1% significance level, and then we have this 761. So the 761, it says, assume that the population standard deviation of prices is 761. So that's going to be our sigma. And then there actually is no mu here. So that 1% significance level is something you're going to learn about in chapter 17. So our population mean mu is not applicable. And then our population standard deviation sigma is $7.61.